I'm Damien. Today I'll be speaking to you about data pipelines. So I'll tell you a bit about me shortly. First, I just want to see a really quick show of hands. So who here today is mainly focused around data? So this might be data engineers, analysts, DBAs. Tiny representation in front. Okay, might be, well, that's fine, that's fine. Next up, so who is more operationally focused? So this might be DevOps engineers, SysOps, architects. Cool, we've got architects in the architecture, brilliant, okay. Fine, for everyone else, coffee machines out front. I believe lunch is at 12 today, and pub quiz is upstairs later on. Cool. So let's get started. This is me. I'm a consultant at Steamhouse in Manchester, and my background is in data engineering and administration. So I've used AWS for about 5 years now. I started with a single dev account, and I'm now responsible for looking at multi-account production setups. Outside of that, I run Webshark, so that's my website with blog posts, projects, and community stuff. And in my spare time, I do a bit of running, a key gardener, and I'm a dog dad to these two psychopaths right here. So, before we get started, on the right, I've got a link to the resources and the slide deck that I'm using today. So this is going to be at the end too, so if anyone wants to get a copy of that, that's fine. If anyone wants to photo any individual slides, there's nothing confidential here, so feel free. So, to start, I'm going to look at some typical problems that are posed by data pipelines. Then I'm going to look at some AWS services that will help solve those problems. Got a couple of demos and use of those services. And then I'll summarise. And then I'll go through some questions at the end, like we said before, where you can come and grab me afterwards and have a chat. Okay, so considering the problems, we're going to be using something called the 4 V's of big data. Now, these go way back, these go back to the early 2000s, and they're used to identify the various dimensions of data. So, what makes it big? Well, it's fair to say that there's a lot changed in those 20 years. So we've got a lot of big things now. We've got things like events, event-driven architectures. We've got API requests going through, things like metrics, traces, logs. So I'll be talking predominantly about data today, but really a lot of it is interchangeable with most of those things, and beyond as well as a lot of other use cases. So the first V is variety, and this is looking at what kind of data is coming in, what kind of process is being run. So there's fundamentally 3 different types of data. You can have structured data, so this is data that's already probably in a database, it's already had a schema defined, already had normalization done on it. Or it might be from a data-specific file format, so it might be Apache backend file, for instance. You may have semi-structured data, so now start to think about things like JSON, XML, or it might be in a NoSQL database. Or you might have completely unstructured objects, so it's now start to think about things like images, videos, and speech. And this is becoming a lot more relevant with AI models that are expected to be able to ingest that kind of content. Also with variety, you can have a variety of intent. So what's actually happening with the data when you get it. So it might just be that you're accepting this data, it's coming in, you're taking it, and you're just putting it somewhere, and that's really all you have to do. You've got no obligation apart from that. It might be that you are a chain, so you're receiving this data from a producer, and then you've got other consumers downstream that you either pass to, or they'll get it from you. You may also need to transform this data, so if you're in the data engineering team, you're going to have your MIT, you're going to have your data scientists that will need that data, but they'll need changes doing to it before they can use it for their processes. I also want to think about sensitivity here as well. So if we think about, for instance, a bank statement. Now, if I run a limited company, I have to publish my bank accounts every year. It becomes a public document at company's house. If I, as a company, accidentally publish a customer's bank account instead, we're talking the same type of document, but a vastly different set of circumstances if that happens. We're talking fines, we're talking loss of trust, and also loss of business as well. There's going to be a financial impact here. On to the next thing, we're now looking at velocity. So we now start to think about speed and delivery. So with delivery, two ways it can come into you really. You can either have a constant stream of data that's coming into little files, but they're coming in on a frequent basis. Or you might have a big wedge of files that are coming in at set intervals throughout the day. You also need to think about your speed of response. So again, admittedly, you may not need to respond at all, in which case it isn't really an issue. But if you do, how quickly are you needing to respond? So is this a synchronous process, something like confirming someone's bank balance or confirming someone's security credentials? That process needs to happen very quickly, or the process that's happened downstream either can't happen or they just happen incorrectly. On the other hand, you might have a completely asynchronous process. So if you're receiving, say, an image file or something that you're going to perform ETL, to an extent, you control that process. You're maintaining the process at that point. You're probably going to have an SLA with your customer or your internal team, but it becomes asynchronous. There's no immediate need for a response. And also there's a scheduling component here as well. So it might be that you've got particular hotspots, you've got busy times of the day or maybe of the month. So you might be a bank and you're particularly busy when people get paid and the bills go up. You might be Amazon with one-off large events like Black Friday or Prime Day. You might be Ticketmaster with a need to constantly scale up and down to let people buy the tickets for Oasis and Taylor Swift. And it's a good job they don't get that wrong, right? Because that'd be terrible, wouldn't it? On to the next one. We've now got veracity, so we now start to think about speed and accuracy, whether you can trust something is what it claims to be. And this boils down to, first of all, you're accepting data from an external party. How are you going to be sure that that external party, that source is correct? What processes are you going to check to make sure that there isn't just anyone that can put data into your location? Is this potentially a bad actor trying to force data into you that's going to be detrimental or further the wrong? Also, when you've got that data, you need to look at the data itself. So is there missing data that you were not expecting? Or has the data changed in some way? So has a column name changed? Because that can break the processes downstream too. Is the data corrupt? So it looks fine, but you open it up and it's just gibberish. Ultimately, the question here is whether you're going to accept this data into your pipeline in the first place. Because if you cut it off at source, you then aren't going to do things like break your data warehouse, break your reporting, your dashboards. And then assuming that's all fine, so your data's been verified, it's been checked, it's healthy, it then becomes your responsibility. So how are you going to protect your data from things like manipulation, theft and loss to make sure that you still have that single version of truth? Okay. Next, we think about volume. So this is down to size. And if you think back to what I was saying before about streaming and batch, this impacts the file size too. So if you've got large files that are coming in, there's the potential there for that download to be interrupted. You might not get all of the data. So what happens then when you think about that? If you're also getting lots of small files coming through, is the potential there for you to be overwhelmed by the sheer volume of data that's coming to you? You need to be able to handle that. So, okay, let's say I've got all this data. Let's say I've got a terabyte of data that I've successfully ingested. So of that terabyte, what kind of access patterns does that have? Does any of it need, for example, rapid access? Do I need to think about caching any of that data? In which case I need to think about what type of cache, what size of cache, because that's all going to have cost implications. Is that data going to go into a database or an app server? Because if it is, it probably needs to go onto a storage volume or onto a hard disk. In which case, I need to think about provisioning size for that. How big is that going to be? And does it need to be optimized for a particular use case? Is it going to be a warehouse? Is it going to be a particular fast-acting server that needs information quickly. If I'm just storing the data, I can probably use object storage, in which case, do I need to have the data highly available? Does it need to be in a higher access tier, where there's more costs, but I can get to it faster? On the other hand, if it's a backup, hopefully, I'll never need to access it at all. So I can put it in one of the lower access tiers, where it's less available, but it's cheaper to store. Speaking of backups, this is another consideration with volume. So you may not need them. If you're getting your data from a third party and they've got a readily accessible API and you can just get data from that API as you need to, you may want to consider just deleting the files when you're done with them, because there's less risk for you that way and lower storage cost. If you are taking backups, then again, that's absolutely fine. You need to think about how long you're going to keep those backups, because you don't want a ton of unused data lying around that's just collecting money and dust. You also need to think about your reason for your backups as well. So if you're going to use them for disaster recovery, let's say it's a database backup, it's SQL, you probably want to keep a couple of months on hot standby just in case, because you're going to need to restore quickly. So your storage needs to have high availability and disaster recovery. High availability and fast access. On the other hand, if your backup requirement is more regulatory based, so you need to keep them, speed is really a factor, just really ticking the box more than anything. You might want to use object storage with a low archival tier, just to make sure that you're still compliant, but it's not necessarily costing you more than it needs to. And within the backup conversation as well comes GDPR. So you can have a customer that exercises their right to be forgotten, and you need to remove that customer's details from your backups. Now, on the one side, you don't want the situation where if you then need to use those backups, that customer then reappears out of thin air, and then suddenly you have a massive complaint on your hands. But you also don't want to break your backups in the process. You need to have them in such a way that you can access them, continue to use them, but not then cause complaints downstream. So I have done this session before. Usually I just get 30 minutes, so I stop here, stop at volume. Now, it has been around for 20 years, as I say. There's a lot more VMs that have come in over the years. And I do have a bit more time, so I want to look at another one as well. And I want to examine value. So this is pounds and pence. It's particularly relevant today in the cloud. So if you think about return on investment for a moment, if you think in terms of a director or a CTO, you're investing in all this storage infrastructure, you're investing in staff to manage and maintain it, and you're investing in the time to comply with things like GDPR, things like risk. So a good question would be, is it all worth it? How is my data justifying all this expense that's going into it? How is my business benefiting from this investment? Because if you could make your data more than just a cost, that'd be great, right? Also got the concept of reconciliation. Now, in finance, reconciliation is auditing your money, make sure that your balances are correct at the end of the day, making sure your money is in the accounts you think it is, and then you update a central ledger. And data isn't far removed from this. So, a side question to thinking about checking your health of your data is actually making sure that you've got the right data in the first place. So, if I'm selling insurance, for instance, why am I keeping all this data about savings? Another question would be, is the data where I actually think it is? So if I think this data is in a database and I go to query it, but it's actually in some file share somewhere, it's not been cleaned, it's not ready for use, immediately got potential access issues. So ideally, you want some kind of dictionary, some kind of ledger, so that you know where everything is. And then we've got the concept of liquidity as well. So liquidity in finance is the ease of converting an asset to money. And probably some of you have got data right now that's doing a single job very well for a report, for a dashboard, and it works absolutely fine. So how easily can you take that data that you already have, you've already cleaned, and do additional things to it to add additional value and growth?
So is it in a big ball somewhere that needs work for every new use case? Or can it easily do things like making reports, train AI models, potentially even be shared? So okay, we've spent a lot of time talking about problems. So let's start thinking about how we can solve some of those problems. So for this next section, I'm going to use the session title as a guide. And just break it up into separate sections with 2 AWS services for each part. Now these are all classic and well understood services, and they'll help you make a perfectly functional pipeline. It's a good foundation for your ongoing work. First part, we're going to look at serverless and auto-scaling. And for that, we're going to be looking at Lambda and S3. So Lambda covers the variety straight away. You've got several languages supported out of the box. And if you need additional support for when that isn't there, you can import custom runtime. In terms of velocity, when you supply the code to AWS, they will handle the auto-scaling, so they're in total control of that. And in terms of volume, you can run up to 1,000 executions of Lambda at the same time. Pointing out that it's across all Lambdas that you have. But if you have particular needs, if you want to focus on one Lambda or a couple of them, you can control how that's set up. You can provision accordingly. Looking at S3. So S3, in terms of variety, you can store pretty much everything you want. And if you need to, you move it to other kinds of storage, say EBS, for instance, or Elasticache, then that's supported as well. You've got a variety of storage cases. So if you have backups and you know you're not going to be accessing that often, they can go straight to Glacier. If, on the other hand, you need speedier access, either leave it in the standard tier, or you can make use of the most recent Express 1 zone for particular use cases. And if you don't know what your access patterns are going to be, or you just haven't decided yet, you can put it in intelligent tiering as well to save yourself a bit of money. In terms of velocity, you can interact with S3 thousands of times every second. So streaming data becomes less of an issue. You just keep throwing stuff out there, it becomes AWS's problem. And then there's a couple of applications for veracity that S3 shines with. So S3 has object lock that can stop objects being deleted or overwritten. You can apply legal holds that way. You can apply versioning, so if you want a version history of your objects as they're being changed, you can enable that too. And you can control access to the bucket itself, so you can use bucket policies and IAM to restrict who can put data in, who can access data, who can take it out. You can also use integrity checks as part of S3 as well. So if you've got large files and you want to check that what you've got is the same as what was sent to you, you can use things like secure hashes, CRC, MD5. These are all checksums that can go in the file and you can compare them before and after without necessarily having to access it directly. And if you want to check the sensitivity of objects, you can use Amazon Macy as well with AI modeling to check what's actually in the data itself. Continuing with S3, I spoke about the need for reconciliation before. So you can use S3 inventories to show what's being stored and where it is within S3. And you can also query that with Athena as well. Now, once you do know what your data access patterns are, you can tailor a lifecycle policy to meet your particular needs and keep your most used data in the higher standard tiers and then automatically move it down to cheaper tiers based on time limitations. And then if you've got mature data sets that you know are in demand and you can legally share them, you can also monetize them as well. So AWS have a data exchange, and this is a managed marketplace, integrates with S3 amongst other AWS services. And it controls access to data sets that you upload with subscriptions. So they can be free. I saw one on there the other day for 48 grand. So depending on what you've got, yeah, it's all there, as long as legal are happy, right? Next, let's look at the data pipeline section. So next two services are the Amazon Athena and AWS Glue. So Amazon Athena, the serverless interactive query service. So AWS handle the entire backend all you have to do is just point Athena at your S3 location and you're away. So there's no server patches, there's no query engine patches. And as a former DBA, I'll tell you this is great. This is less stuff to manage. This is less plate spinning. This is less being up at 9:30 in front of your computer. You can also control access to control access to Athena with IAM as well. And within that, you can use Athena workgroups. So these let you control access to particular workgroups on a team level. So you can control what kinds of data they can query. You can track the queries themselves as well, so you have a higher level of observability. Now, Athena originally was read-only, so you could read from S3 and make no changes to it. So for veracity requirements, that's absolutely fine. You know there's no accidental changes, like can sometimes happen in SQL databases. Now, it doesn't fit every use case, though, because again, you may have a GDPR requirement to change some data in S3. You may have a data lake that needs those changes. So Athena now supports Apache Iceberg. And at the very top level, this allows row-level changes to data in S3 from Athena. And as well as that, you can also create derived tables in Athena as well. So the concept of a derived table, let's say that you've got two data sets. You can then write a query, join them together into a single one. And there's a couple of applications for this. So first of all, you can explore the data using standard SQL at that point without having to open the files and go into them. You can also begin to craft ETL as well. So you can, before you even start development, you can run a few queries in Athena and check that the data is going to be what you expect. You can also release those tables to your MI and analytics teams. So you're no longer exposing the original data at that point, you're exposing the derived table. And this also supports the idea of data lineage as well. So data lineage it's quite a recent idea, and it's gained a lot of traction with AI. It's the idea that you can track where the data's come from to get to the point where it is now. Rather than it just being this vast estate, you can pinpoint the source of the data and then track it through its various stages to what's being read now. And a derived table is basically create a table, join this one, so you can see it's right in front of you. In a similar vein to this is AWS Glue. So this is AWS's ETL tool. And I appreciate there are more architects and data engineers in the room, so just to clarify, ETL. So the E is for extract, so that's extracting the data from the source. T is transform, so this is things like setting your data types, removing blank data, renaming columns to make it fit. And then when you're done, the L is for load, so that's loading your data to somewhere else. It might be an S3 bucket, it might be a database, or just wherever it needs to be for ongoing processes. So AWS Glue has a couple of different tools to offer. You've got Glue crawlers, and you just point those at a location, and they will then go away and they will discover and catalog that data for you. You can crawl a variety of locations, you can have 1,000 of them per region, and they'll go away and they'll check things like what columns are in there, what data types are in there. It's a big time saver. Now Glue also has a data catalog, and you might think of this as a ledger. So you can update this either manually or automatically. Crawlers can do that for you. And ultimately this tells you what data you have and where it is. So S3 inventories will cover you for S3. Data catalog will go beyond that. So if your data's in Aurora, if your data's in RDS, if it's in DynamoDB, you'll be able to see all this from the data catalog. And you also get ETL jobs, which we'll examine more closely in a second. But you can run 2,000 of them at the same time, so again, your velocity requirements are covered. So, considering ETLs, I spoke about value before. So ETLs add value to the data. We spoke about liquidity, about the ease of using the same data for multiple processes. So, if you have a good ETL process, if your data is properly cleaned, properly catalogued, and it's in a ready state, then it's far easier to reuse. You get minimal work for every new use case. So if you've got a new dashboard or you need to train a new model quickly, then your data's ready to go, right? It's also easier to analyze clean data as well, so your MI teams can get insights and trends that weren't necessarily obvious in the raw data. Now, ETL can create efficiencies as well. If you remove any unneeded columns, you make the data smaller as a part of your ETL process, then it means your files are smaller. So it means your storage costs are lower. You're paying less for S3, you're paying less for your ODS storage. You can also convert legacy files like CSV and Excel to more modern formats that are optimized for faster reads. And these are usually compressed too, so again, they get smaller per design, so you're paying less. You've also got Glue quality checks that I wanted to speak about as well. And I've mentioned here that they can prevent downtime, so I want to expand on that. If you have data quality checks and they are constantly passing, then it means your data quality is consistent. So that means your data is consistent, you've got no issues. If, on the other hand, your data is not consistent, if the quality checks are not coming back consistently, it means your data, at best, is inconsistent. At worst, it's just outright wrong. And that leads to problems. That leads to things like reports breaking, dashboards stop working, and your AI model that you've trained for months on this data suddenly isn't useful anymore, and everything stops. Now, at best, here, there are money or time costs to get everything back online, to get yourself back to a state of full readiness. At worst, potentially lose months of work, and you face customer and business detriment. So your quality scores then become an early warning system that protects you from bad data before it necessarily starts to have an impact. Speaking of scores, you can track them over time, and that proves that your data is accurate, and it proves that it's valuable. It lets you build confidence in that, both within your team and externally as well. And you can also use them within AWS for event-driven processes. So there are APIs in AWS that can check the score of a particular run. And you can have something like, if a score is below 90, send an SNS report and stop the ETL. Do not use that data to stop any more processes. So I've got a demo of what Glue data quality looks like. This demo shows a summary. It shows a data quality chart. It's going to show a recent run, and then the job histories as well. Okay, so this is a data quality check for a view statistics Glue table. And straight away you can see there's a line graph we'll scroll down to shortly. This shows the quality score out of 100% over time. You'll see that it shows the last 10 runs. Now each run has a tooltip. You're going to see shortly, it starts at 90% for the first one. Okay, and then over time, that's slowly going to increase to 100%. Now, this graph happens automatically, and you can show it to your MIT, your auditors, your C-suite. Now, if I scroll down, we're going to see a data quality rule set. And this is going to show the number of rules, when it was last run, and the most recent score. So you can see there's 20 rules here. There we go. Okay, so if I now expand the rule set, we're going to be able to see each individual rule as part of the set. You can see whether it's passed or failed, and you can see what came back from that rule as well. So just let that sorted out. Now, most of the conditions here are pass or fail, so the return is 1, 0. So I'm going to focus in a second on rules 2 and 10. There we go. These are both looking at ranges, so you actually get the number that came back, as opposed to just a Boolean value, yes or no. So next, let's look at the job histories. Now, first of all, you're going to see a summary of all the runs for the past month. And you can also see there's a recommendation tab too. So this is where Blue's AI has scanned the data and recommended rules to use. You can either use that as a basis or go on your own path, just see what it suggests. So if we now go down to the list of runs, you can see that some have passed and some have failed. And within that, you can see how many passed in that particular run. So I'm going to expand one of the fails so we can see a little more detail about what's happened. So we're going to see in a second that rules 10 and 12 have failed here. We'll just move things around a bit to get a clearer picture. So if you start to focus on rule 10, we'll get an arrow in a second. Rule 10 was expecting a value of either 0 or 1. It actually ended up getting back 93, which is why it flagged the fail. And you can use this then to make decisions on how you're going to respond to that. It might be that the data is wrong. It might be that 93 is wildly inappropriate and it shouldn't be there. It might be, equally, that the rule itself is broken and needs changing. So this rule should actually have been 100. I completely missed it when I scanned it, but it looks good then, right? So now let's talk about automation. We've got to the point that we've got the ETL, we've got everything in place, but we don't want to be running it ourselves, right? We've got multiple services in play, and we need to tie them all together. So we're also going to need some orchestration. So final two services, we'll be using step functions and event bridge. This is going to tie the pipeline together. So with step functions, the orchestration tool we're going to be using, in terms of variety, it supports pretty much every AWS service. You can either script them as code, or you can use Workflow Studio, which you're going to see in a demo shortly as well. So the Workflow Studio writes code automatically, and it basically lets you fully automate the process, because it'll spit code out when it's done. And you can apply that code really however you want. You can put it in CloudFormation, you can put it in Terraform, and it means that it'll do the same thing every time, every account. You don't have to worry about it anymore. So again, back to veracity, you can guarantee your processes. And to an extent, self-documenting as well. In terms of velocity, you've got two choices, and it kind of depends on your process. So if your process is people or batch-driven, and you've kind of got that unavoidable latency, you're having to wait for something, probably better with standard workflows, because they've got a long wait time, and pretty decent free tier as well. On the flip side, if your process is API or streaming driven, you've got lots going on, need things to happen very quickly. You've also got express workflows as well, which are more tailored towards faster use cases. So before I go on, has anyone used Workflow Studio before? Good, good. Well, you're about to learn a bit later. So before I show the demo, before I lead into that, I'm just going to show a little bit about what everything is. So this, there we go. This is the step functions workflow for those new to it. So there's three main parts. First one, on the left, you've got the list of AWS actions you can choose from. You've got the popular ones at the top, and you can see by the sides of the arrow next to it, there's a lot there. Pretty much every AWS API call covered. In the middle, you've got the design graph. So this is where you actually make your workflow. So you drag and drop from the left to the center. And then on the right, you've got your workflow customization. So this is where you do your configuration. And this changes depending on what's selected, which you'll see shortly. So three things in this demo. We've got a Lambda function that's going to call the WordPress API in this instance. And it's going to store the data as JSON in this string. Then got a glue job that's going to be performing ETL on the S3 data. So you can see there's a parquet for that. And then finally, we're going to have an Athena command that's going to do a bit of back-end updates, just going to update some partitions. Okay, so we'll begin by dragging a Lambda action onto the graph. And then we're going to see options for config for that Lambda function. And there's a couple of different points here. So first, there's an integration type. Some actions are optimized for easier use with step functions. And in Lambda's case, it's going to give me a list of functions that are in this AWS region. Just saves me having to type them out in Discovery. Now, to show the difference, If I change from optimized to SDK, you'll see the drop-down changes to a JSON object instead. And I can now do things like pass parameters to the Lambda function from the workflow. I'm just going to flip that back. So now I'll choose a function from the list. There we go. And that's really all I need to do here. So this workflow, when it starts the Lambda function, it'll wait for it to finish before starting the next action, which is going to be the glue start job process. It's going to run my ETL. Now you don't get a list of glue jobs here. I'm just going to type it in manually. Now, by default, what's going to happen here, the workflow is going to start the ETL, and then it'll immediately move on to what the next action is going to be, which is mostly fine. I don't want to do that here, though. I want the workflow to wait for it to finish first. So there's an option a bit further down, which is literally wait for tasks to complete. So I'll enable that. Now, without this, the Athena query that's going to be next, it's going to run too soon. It's going to run before the ETL finishes. So that's not going to happen now. If we look at the next state, this is currently set to end. It's going to stop the workflow. Now, the Lambda action has actually already been changed. If I go back to that for a second, you'll see it's now pointing to the glue job. And finally, I'm going to put the Athena step in. So I'm just going to run a search for that first. Okay. So what I need to do here is tell Athena what query it's going to run. And this is similarly to how you would do it with the Athena SDK. So I'm just going to paste the query in. Okay, so now that's it. So Lambda gets the data, Glue does the transformations, and then Athena updates the partitions. Now, admittedly, it's quite a simple example. There's nothing here like error handling, there's no observability. This is not production ready necessarily, but it's not bad for 3 minutes either, right? And I will show a couple of examples later on, if we get time, with additional functionality like observability and branching paths. Okay, so finally, I'm going to look at the Event Bridge Scheduler. This is the automation service. It's also one of my favorites. So I'm a consultant, right? And I used to be an engineer. So by design, I hate time zones. I love anything that will make them easier, and that is this. So in terms of variety, again, same as step functions, covers pretty much every AWS service. You've got a choice of schedule. You can either have a set time, so it could be say 7 a.m. each morning, or a fixed rate, so every hour. And in terms of veracity, you're covered here with at least once event delivery. So when you send an event to a target, it confirms back to EventBridge that it's been delivered successfully. And if that doesn't happen, we've got things like retry policies, dead letter queues that you can see in the final demo. So this demo, 3 things going on. We're going to set a schedule, we're going to set a target, it's going to be the step function workflow, and then we'll just run through the options for IAM, retry policies, that stuff. Okay, this is a new schedule. I'm going to start by setting the name for it. Okay, and then we're going to set a schedule pattern. So 2 choices here. It can either be one-off or it can be recurring. I'm going to select recurring. 2 more choices now. You can either have a cron-based schedule, so you give a cron expression and then you can code that however you need to. Or you can have a rate-based schedule. And this is going to be either minutes, hours, or days. And I'm going to set it for every hour. Now below this, there's a flexible time window setting. If you're triggering lots of actions as part of your schedule, this is something that lets you stagger them over a period of time so you don't encounter things like throttling with other AWS services. And I'm just going to turn that off, don't need that. Next, I'm going to select the target. Now, there's a bunch of targets here, a bunch of templates, and these are all for common AWS services. So in the bottom right, I've got the one for step functions, so let me execute that. Now when I select this, it'll take me down to configuration. And I'm going to select my step function from the list. You can see here, in the same way as if I was running it manually, I can also put JSON in plus 2, so I can use the generic step function tailored to my needs. Next screen is going to have the settings. So first, I can choose whether the schedule starts life enabled or disabled. And then, if it's got a limited run, after it's done, I can choose whether I only keep it or let AWS delete it for me. Now we've then got the failure settings I was speaking about before. And you've got a couple of options here. You can either set the retry policy, you can retry if it fails. You can also set dead letter queues as well, so if you've exhausted your retries, you can use an Amazon SQS queue and then get notification of what's going on and capture your events. You can encrypt events as well, so if they contain sensitive data, you can protect that. And you also set an IAM role here too, which will let EventBridge access its target, in this case the step function. And then just have a quick look at the summary. So this is details about the schedule that I've set. And then it'll scroll down and we've got details about the target, so I can see the step function. And then the settings that I've got around IAM and retries, etc. And then lastly, sorry, I'm moving ahead. At the very bottom is the option to create it. And you're done, schedule's live. Okay, I did say I'd go through some quick examples, just to show you those briefly too. These are other examples of step functions, other pipelines you can build. This is for code build. So this triggers a build, gets the test results for that build, and then checks those tests. So you can see there's a branching path here. If it passes, then you get a report by SNS. If it fails, you get an alert as well, so you've got your observability, and you can automate that build by EventBridge, so you can run everything on it. You've got an AI use case as well. So this automatically tunes a model. It's using Lambda for your path movement, for your data movement and path extraction, and SageMaker for tuning and inference. And you can put EventBridge onto that as well if you need to. So let's summarise, let's draw everything to a close. So what have we gone through today? We went through the 4 V's of big data and how they apply to a modern data landscape. We used several AWS services to build a data pipeline. Showed you some demos of Glue, step functions and EventBridge, and we saw briefly some other step functions use cases too. So that's the session. The social links are on the left. On the right, we've got the slide decks and resources again if you need to. So I hope that's been helpful. Does anyone have any questions?
Yep.
Hi, thank you. So you were talking about mapping value with S3 life cycles. Can you tell more about that?
Yeah, so the idea with that would be, if you've got data that's particularly high value and you want it to be accessible as often as possible, if you keep it in S3 standard, then that's kind of your optimal place for it. What I've found, like in my previous roles particularly, you tend to get once data's been around for a while, it's accessed less often. It starts to lose some of its value, or it's been put somewhere else. So if it's in a database, or it's been used for a model, then it's in the place it needs to be. So your data in S3 at that point is kind of costing you money where it doesn't necessarily need to. So the value there, take that data, let's say it's costing you $5 a month in standard. If you then start to knock it down, say in frequent access, or potentially even glacier deep, if you know you're not going to touch it for years, 48-hour access point isn't really a factor, and it's costing. I'll give you an example actually. I've got some backups in my account. I pay a fine for them, like the stuff that I care about. That same stuff that I'm storing in glacier deep access is 30p. So that's where the value comes from there. You can get value for generating money, but also for saving it.
Thank you.
Right?
I've got a question, mate. Do you know what that £48,000 data set was?
Yeah, I can't remember offhand, mate, but it's kind of, I went on just to basically make sure I wasn't talking crap, it's like free, and then it suddenly appears 48 grand for 12 months. But yeah, if you filter, I don't think you can filter by value, but I think if you filter by, I can't remember the filters for the life of me. But yeah, have a look, it's crazy. If you think about like Because there's companies there that look at that and go, bargain.
Does it show you the data quality?
So I think if you look at it, it shows you things like schema. It shows, you know, you're not just going in blind. You want a certain amount. I didn't look too closely, to be honest. I was kind of mesmerised at the... But generally, if you go on, you get an idea of what you're getting. It's kind of... part of the marketplace is it enables you to open a dialogue with that company. Because it's the same as the EC2 marketplace, where you can sell compute you don't saying you're not using it. You might as well generate some income off it. So you're kind of opening a dialogue with that company then to say, I'm interested, you know, is there any negotiation on wiggle room on this 48 grand perhaps? And you probably want to check, you know, this is my use case. Does your data fit that, or am I about to blow 48 grand?
Yeah. Plus. Yeah. Before everyone leaves, can you just give one more round of applause to Damien? Thank you very much. And I've also just been informed, unlike the new iPhone 16,